Good afternoon, folks. Ooh, it actually yesterday it didn't sound like this, but um, it is my pleasure and honor to be able to introduce Kathy Jacobs to you today. So as I guess it says up here, Kathy is a professor of environmental science and director of the Center for Climate Adaptation Science and Solutions. And I want to emphasize that science and solutions. We have lots of entities that are all about science, but there's more to it than this. And so she has expertise in water policy, water management implementation, and her work focuses on connecting science and decision making. And in order to be able to do that, one of the things that really helps is that Kathy has a very different career path than a lot of professors at large universities. She worked for 23 years for the state of Arizona for the Department of Water Resources there, went to the federal government, was in the Office of Science and Technology Policy, where if you heard her yesterday, you know that she was director of the third National Climate Assessment. So, you know, very large job with a very large potential impact. And so what that means that she is a professor, but unlike most of us who are in faculty, she actually has insight into what works in the real world. And so with that, I'm going to let her tell you how.
Am I on?
You are on.
Okay. Thank you very much, Mark. Well, hello again, and hello to people who are new since yesterday. I'm really pleased to be here and have an opportunity to talk again about things that I care a lot about. In this case, I'm going to be talking about moving beyond climate adaptation versus mitigation, because I think that these two communities have been operating separately for too long, and we need to be thinking about both managing greenhouse gas emissions and managing risk as we're dealing with building climate solutions. It turns out it's really two separate communities that are doing this kind of work, and along the same lines of what I was complaining about yesterday, we really need more integration between these fields and between the people who are doing the work in order to make sure that we don't have unintended consequences, because right now a lot of the investments that are being made probably are leading to, or either have led or will lead to, unintended consequences. Before I proceed, I want to note that some of the material that I'm using in this presentation is derived from a conversation that we had at the National Academies last summer. It was a Hauser family, I think it is, lecture focused on the issue of where we are in adaptation and where should we be. And several of the other panelists had a lot of good ideas, and so I've incorporated them into this presentation. The other panelists were Lisa Dilling, Mike Vandenberg, and Dan Kamen. And I've added Susie Moser to this list of people I'm thanking, because I think she is just a major thinker in the adaptation world, and I've been really influenced by her ideas. So wanted to give credit where credit is due. So as was mentioned, I did spend some time in the White House, and one of the things that John Holdren, the president's science advisor, was fond of saying was we don't really have a lot of choices here beyond mitigation, adaptation, and suffering. The question is, are we going to make decisions that limit the suffering and do more adaptation and mitigation, or are we going to essentially be victims of our own policy decisions? And so the question is, what is the mix going to be? Are we going to manage greenhouse gases sufficiently that we are actually able to adapt to the climate as it's changing? Or are we going to be victims of this situation and really experience a lot more suffering than we need to? So I think this is a really important trade-off set. It's not like everybody wants to understand this, because these are not easy choices, but being a victim really shouldn't be the choice that you make. It's what can we do to manage suffering, manage risk, and potentially really pursue opportunities. So I'm going to use these words a lot. I just want to make sure that people understand the difference. In the climate world, the word mitigation means something different from what it means in many other parts of society. Mitigation in the climate world means managing emissions, measures that reduce the amount and speed of future climate change by either reducing emissions of carbon dioxide, methane, and other heat-trapping gases, or removing carbon dioxide from the atmosphere. So carbon sequestration is a mitigation technique. Adaptation is an adjustment in natural human systems to a new or changing environment that takes advantage of beneficial opportunities or moderates negative effects. So you see, adaptation doesn't need to be all about negative things. It can really be about setting yourself up for making money and for successful outcomes. It's not just looking at the downside. And then I think it's really important for people to understand the concept of maladaptation. Many adaptation projects actually can make people more vulnerable rather than less. And we've seen projects of this kind across the globe for a long time. And of course, there may be some who argue that adaptation projects such as dam building in third world countries, which was the favorite activity of the World Bank forever, was definitely one of these top-down kinds of adaptation processes that in many cases, at least for some communities, turned into a maladaptation. We need to think about not just the consequences today, but the consequences in the future of these decisions, which of course is a hard thing to do because we don't have a crystal ball and we don't know what the future is going to look like. But at least if you try to think about those things, maybe you won't do what's in these two pictures. So I took the picture of the house standing in the middle of the marsh close to Newburyport, Massachusetts this summer. It's literally a tidal marsh with sea level rise happening and essentially a dirt road that leads to it. And yet this is a brand new house and it is for sale. It's just beyond my comprehension that supposed land use planners are allowing this kind of thing to happen. I mean, this is an accident waiting to happen and they won't have to wait very long. And then this other example here, which is the seawall, and I actually don't remember which third world country this is, but essentially that seawall was clearly intended to prevent impacts of sea level rise or storm surge on this community, but actually what it's doing is trapping water behind it and probably not protecting anybody. So these are the kinds of things that often seem to happen, but there's a whole array of adaptation efforts that are very well intended, but which have had consequences that were not understood. So we need both adaptation and mitigation strategies, but we do need to understand how mitigation strategies interact with adaptation strategies and try to set up opportunities where we're both managing risk and limiting greenhouse gas emissions. I'm sure you're all aware, for example, that when you build a concrete wall, concrete involves a lot of greenhouse gas emissions. So there is a mitigation consequence associated with that one thing. But that's sort of a simple example. Desalination is, at least in the words of my immediately former governor, is the magic bullet for Arizona's water supply situation. Oops. Oh no, that is where I'm supposed to be. But clearly, adaptation, I mean, if you're really trying to adapt to a drought situation in a long-term sustainable solution, you have to think about the energy implications associated with desalination. And so there are potential negative consequences for mitigation associated with that particular adaptation. And then in the context of renewable energy, of course, we all understand there has to be a reliable source of energy. So you can actually increase your risk if you're entirely dependent on renewable energy and the wind doesn't blow or the sun doesn't shine. You have to have some kind of backup power. Lots of people are now depending on, for example, hydropower as being one of those backups. And that works fine so long as there's water in the river that's generating the hydropower. But you have to look at these intersections between the adaptation and mitigation piece. And then also many people don't think about the energy implications of new construction. So they might, for example, look at greenhouse gas emissions associated with building a facility or an electric vehicle or whatever, but they may not think about what the implications are for maintenance and long-term energy use. So it's important to think about both sort of the capital piece and the operations piece of whatever the investment is. So I want to talk a little bit about my own perspectives on what successful adaptation looks like. There's a whole, I have a whole list of constraints or limitations on successful adaptation, and then I have quite a few sort of positive aspects going forward. But I think this particular diagram of adaptation activities does emphasize one of the things I was talking about yesterday, which was the importance of learning. So this idea of implementing decisions, monitoring, and then going back to what's the problem now and what are the objectives. But there's also some other learning loops within all of that. And if you don't close these loops, of course, you're not going to probably have successful adaptation. But I love that this particular version includes the part about problem defined correctly, because honestly, I do think that's where many people go wrong, is not agreeing on what is the problem you're addressing. And if the problem you're addressing is actually looking broadly at climate solutions, then you really do need to think about not just are you managing risk, but also what are the energy implications and emissions implications of whatever it is you're doing. So I'm going to start this long list of challenges, which I'm sure will be depressing, but there is a long list of solutions also. So first of all, success and adaptation depends on who gets to define success. And as I think I probably pointed out sufficiently yesterday, success is in the eye of the beholder, and often reflects your own worldview, your own role in a project, your role in the community, sort of how broad your vision is, whether you care about plants and animals or you only care about cost benefit, a whole array of different things. And so if you're planning to make progress with people who actually don't see things the way you do in terms of what is success, you need to have that conversation. What is it that we're trying to accomplish here? And can we sort of agree on what success looks like? The second is there are always issues with how the costs and benefits associated with adaptation and mitigation are sort of roll out. We understand that the government ends up paying for a lot of potentially post-event kinds of expenses, especially if you have an extreme event and you have a lot of repercussions. The federal government almost always is stepping in at that point. But it's really common that people don't think about who else is really paying, or what are the consequences in terms of non-monetary conditions in this area. Is the ecosystem going to take it in the shorts? And that hasn't been reflected in the cost benefit analysis. Is whatever it is that you're going to do on the coast going to really protect this community at the expense of the adjacent communities? All those kinds of things. So thinking broadly about both who's paying and who's benefiting from all of these investments. And unfortunately, what you find is often the people who are paying are the people who are most vulnerable, and often the people who are benefiting are rich people. just a generalization, but it often happens that way. Some adaptation efforts increase greenhouse gas emissions, as I've mentioned, exacerbating the effects we are trying to manage. So just have to look out for that. And of course, some mitigation efforts actually increase climate-related risks, and I've given an example of that already. So adaptation can also introduce new kinds of long-term risks. For example, importing water for irrigation in order to offset increased drying, and we've seen this happen particularly across the Midwest, across the Ogallala Aquifer and so forth, as things have gotten hotter and drier, or as people have wanted to ensure a more reliable crop, they've imported water supplies. And that is all hunky-dory until that imported water supply actually gives out. You may actually have increased your risk by depending on an imported water supply that might not be reliable itself. And similar things with levees. You know, you look across California, there's all kinds of places associated with the Bay Area and the Central Valley that are currently protected by dikes that are on the brink of falling apart. And so, yes, the dike is a nice thing that the dike is there, but if you don't know for sure that that dike is in great shape, if you are counting on it to protect your house or your farm or whatever from flooding, you may actually be sadly mistaken. And then there are a lot of not in my backyard kinds of things. So many cases, and I think someone here in the audience has worked on wind energy and how upset coastal property owners get from having, for example, having generation facilities out in the ocean that are disturbing their view, or in the case of the Bay Area and California, talking to wealthy landowners about the fact that they are likely going to have to either raise their houses up on stilts or move back in the not too distant future. And the people behind them are like, no, you can't raise up those houses. I can't see the water. So, you know, a lot, it's, the not in my backyard thing is a huge problem, particularly if the communities that you're trying to do this in have a fair amount of agency. You know, if they are actually capable of speaking out, they may very well just squash the whole adaptation effort because they don't want to affect their own property. And then environmental justice issues, sort of broadly speaking, as opposed to social justice issues, really there aren't as many spokespeople to sort of help articulate what the consequences are. And it's pretty hard to make arguments sort of in a sort of squishy social science way when everybody else has dollars and cents that they can use to sort of fight back. There are only 12 of these challenges, so bear with me. So climate change is a wicked problem. It is pervasive, it is unpredictable, and it is intergenerational. And of course, that does discourage a lot of people from taking action. That being said, it also is empowering to know that there are ways to take action. And so that's really the way to counter that, that particular challenge, is to help people see what their own role can be in dealing with these issues. But there is a significant risk of cascading effects associated with individual climate impacts. So I think lots of people don't understand, for example, that when you have a heat wave, you might also wind up with a wildfire. And if you have a heat wave and a wildfire, you may disrupt the electric grid because the electric grid can be actually shut down by particulates and smoke. And then you have people who can't use their air conditioning, and then you have people who are having serious health problems and asthma, and then you have the possibility that your healthcare system isn't getting electricity because the electric grid is down. And so you've got this whole cascade of potential health and safety and property issues that are connected to one thing, which is this heat wave. So people fail to understand these cascading effects and tend to think about impacts individually. And so when you are working on adaptation, you really need to think about, is this adaptation going to work in the context of possible system failures caused by these cascades? Context is critical. I think we're all aware. The social situation, the economic situation, the geography, the history of each community is different. And what's acceptable in one community or what physically works in one community is not necessarily transferable to another. We need to avoid focusing on short-term risks, which particularly with sea level rise seems to be the way people are going. You know, they put up a little, something to try to limit the wave action and erosion on their own shore, and don't think about, okay, what is the longer term picture here? It is much easier to grasp what the short-term risks are, and it takes more imagination to think about the longer term. Externally funded adaptation is different from empowerment. So, somebody from the federal government flies in and makes a decision about how you're going to, your community is going to recover. This is particularly a problem when the global south is being sort of taken care of by the global north, sort of imposing solutions on areas that may not actually want those solutions. This can actually be very disempowering and really entrench these unfortunate power dynamics that make people feel more helpless and have less agency. And then anticipating the spatial and temporal change of climate impacts is a serious challenge, especially if you're crossing jurisdictions where the jurisdictions may have different capacities to respond or different interests in responding. So for example, the Colorado River, we're involved in this crazy conversation now between 7 basin states and, a large number of tribes with allocations and tribes that don't have allocations and Mexico, and trying to manage all of these interests and considerations across state boundaries and international boundaries is much more challenging than if you're trying to do it all within your own city or whatever. Okay, so now I'm going to talk about solutions. Sorry about all that. So first of all, there are actually lots of co-benefits at the intersection of adaptation and mitigation. And I'm sure you've heard about, all the positive things that can happen in the context of green infrastructure. If, for example, you're trying to build a more flood-proof city, and you, instead of channelizing all of the water, you try to broaden the floodplain and create parks and create, trees and green space, particularly in parts of cities that are overheating now or don't have access to recreation. There are a range of possible benefits associated with forest management, including generating forest products and possibly increasing wildlife habitat. Also, there are other things associated with forest management that don't always turn out to be positive, but that you can definitely identify positive outcomes that are co-benefits, recreation or otherwise, associated with forest management. Sequestering carbon in farmland, again, a little bit controversial because it's not clear how long that carbon is going to stay in the soil, but it's good for farming to have more carbon in the soil. It retains more moisture, etc. And as I've said before, an important solution is clearly and collectively, meaning jointly and collaboratively, defining the problem that you hope to address, ensuring that a broad intersection of affected parties can engage in the decision process in a legitimate way. And I do want to talk about this for a minute because, honestly, so many people feel like, oh, well, I took care of stakeholder engagement. I had a meeting with affected parties and, they had an opportunity to talk, but they didn't say anything. So that is not stakeholder engagement, and that is really not a legitimate way of hearing people's voices. You need to figure out, in what circumstances are they comfortable talking about what they're concerned about, and they need information in order. In many cases, they may not have the full suite of information that's necessary for them to engage in a meaningful way. And so they just sit there and are quiet because they're listening to experts and they figure they have no idea how to respond to what they're hearing. But you can create environments where people really do they're feeling empowered to be part of it and they don't feel at risk when they're sharing their perspectives. And you've given them enough information in a way that is not condescending that they can truly engage. And so this is a theme in my career from the very beginning. It's really bothered me that people feel like, well, they had a public meeting and there was a microphone and those people didn't stand up. So too bad for them. But that is just not a legitimate way of operating. In the water management arena, where I've spent most of my career, I've seen how the experts dominate the conversation and they'll just shut down right away somebody who has an idea that is inconsistent with the current institutional framework. And they're just like, no, that's not possible. Next. As opposed to, let's explore what you just said and whether there's another way to accomplish what you just said that is within the institutional structure, or et cetera. You get the idea. But anyway, I'll stop haranguing about that. But I do think it's a critically important thing. You know, everybody has good intentions, but putting yourself in the shoes of the other person is particularly difficult, especially if you're an academic. You know, they don't have the resources that you have. They may have far more local knowledge than you have, and you may actually be totally out to lunch, and they may absolutely have much better ideas than you do. And so if you're not setting it up so you can have a two-way conversation, then you're going to be sorry. So anyway, enough about that. Agreeing on definitions of success, I already talked about that. But also thinking about multiple scales and timeframes. And this comes back to, you know, if you solve a problem that is defined in a small boundary, that's actually a lot easier to do than if you think about that solution in the context of a much broader regional system or solution. So, you know, you're trying to mitigate flooding or you're trying to deal with drought. Perhaps you can solve the drought problem of your own city by stealing water from some irrigation district, hypothetically. But you may not realize that what's happening in that irrigation district is there's actually return flows from that irrigation district that's supporting a wildlife refuge that's downstream, and you didn't know that. And so, you know, just understanding that you have to look at these, both the problem and the solution across multiple time and space scales is an important lesson that I'm afraid a lot of people miss. Also framing this not in terms of, you know, this is a new problem, this is a new threat that's coming from climate, but rather climate change, it provides an overlay of increased risk across a whole array of existing vulnerabilities. But managing risk is something we know how to do. I mean, we all manage risk. You know, when it's raining, we take umbrellas. When it's cold, we bring coats. You know, when there's traffic, we pay attention to whether the light's green or not. I mean, we do all make decisions on a daily basis that are managing risk to ourselves and hopefully to our communities. This shouldn't be a foreign concept. And so if it's looked at as managing risk as opposed to fighting climate change or whatever, you know, just a framing that really, I think, helps. So speaking of framing, I'm going to spend some time now talking about framing problems to combine risk management objectives with reductions in emissions. So I'm going to talk a bit about water management. I know at least some of the people here hoped I was going to say something about water. Sorry to all you ecologist people, but I realize many of you actually realize water is what's driving your ecology. So integrated water management is one option, but if you look at a portfolio approach across a whole array of different options, sometimes you can find a set of solutions instead of one silver bullet kind of thing. So I really encourage people to think more broadly about whatever the water problem is, and think about other problems that could potentially also be solved. So this integrated water management idea is really matching quality to use. It's not a new idea. And yet there are many communities that still think of their wastewater as being a negative or a waste product, as opposed to a source of additional water supplies that could be used in new ways. And really the only difference between potable water and wastewater is money. You are able to treat now, I mean, we've got the technology to get from municipal wastewater to drinking water. And we all know that it's possible. Whether it's politically expedient is another question. But you don't have to go all that distance. You can, in fact, treat it to a point where it can be recharged for future use in the aquifer, or it can be used for turf applications or agriculture, especially if it's for non-food products. So at least in Arizona, this is normal. I mean, we have been reusing municipal effluent since 1981 on a very large scale for all our turf facilities and so forth in the Tucson area. So this is not new news, but it is new news in some communities. So just throwing it out there. We have also made huge progress in storing vast amounts of water in groundwater aquifers. And of course, not everybody's got a groundwater aquifer that happens to be depleted so that you have plenty of storage space. But that's an opportunity that you've got an aquifer that's lost some capacity. Conservation, really is the starting place. If you are focusing on conservation, you often are saving energy and water, and efficiency can lead to great outcomes. Efficiency also can lead to unintended consequences along the lines of what I was just talking about. If you have, for example, an inefficient agricultural operation where the water is actually recharging an aquifer that's being used for other purposes, it may be that, eliminating that waste isn't going to help very much, or you might actually be damaging habitat in the context of conservation. So conservation is a double-edged sword, but it often is the first adaptation option that people need to look at. Stormwater capture and storage, again, makes all kinds of sense. In some cases, it doesn't make monetary sense, at least with near-term economics, but it might thinking further into the future. We talked about green infrastructure. Reservoir reoperation is another huge opportunity. Many of the reservoirs in the West are being operated according to rule curves that were essentially created, decades ago, could probably be updated in the context of current capacity to do seasonal to interannual prediction, and really be reoperated to accomplish more goals. And I know several people in this room do that kind of work. Mainstreaming is another sort of opportunity. How is it that in all the decision processes that we're making, whether it's reconstructing infrastructure or trying to rebuild or build new communities, how can we integrate all of these new ideas as we build new infrastructure so that it's more robust, so that it's less likely to be impacted by heat or drought or flooding, so that it's sized properly to deal with increasing wind strength, etc. So there are all kinds of ways, and I believe the American Society of Civil Engineering has actually been changing a lot of their standards to try to deal with this fact that, that we were looking backwards historically to see what kinds of climate events we needed to be prepared for. And now they've acknowledged that we need to be prepared for the ones of the future, not the ones of the past. And so therefore there are some new standards. But it's a great opportunity to realize that a lot of the infrastructure that we will need by the year 2050 doesn't exist yet. And so we have all these places to make better decisions as we're moving forward. And then I think a much maligned opportunity is really land use planning. And I know there are people in the audience here who are excited about the connection between land use planning and adaptation. But we can make huge differences in our energy demand and in our water use and in our risk management by managing land more appropriately. So I think about some of this as the water G perspective, like combining energy and water outcomes and thinking about technology solutions in the context of whether they are energy intensive or not. You know, many of the technology solutions actually do require a lot of energy, and Arizona is currently in the market for moving water from the Mississippi and from Mexico into the state. I mean, huge water transfers being considered again in ways that I would never have anticipated would be taken seriously. But we do need to look at what the energy component of all of these potential solutions really is, knowing that energy intensive options, especially the ones that require fossil fuels, will be less attractive in the future. Which brings me back to the double benefits associated with conservation, because often water conservation does save energy as well. So just thinking about this in terms of reframing. I'm sure you've also heard of the idea of adaptation pathways, which are really a combination of incremental and transformative solutions. Transformative solutions usually involve actually changing systems or moving communities or making more substantial investments that prepare you for the longer term. Incremental are usually more sort of dealing with short-term risk, but there is a way to link them through this idea called adaptation pathways, where you identify triggers in your system where you'll move from one pathway to another. And so in this example, which is from Southeast Australia, they're actually looking, and you probably can't see this well enough to read it very well, but they've identified three levels of triggers, and they will use different adaptation strategies until they reach the trigger, and then they go to a different strategy. So in this case, the first one is inundation of the esplanade, and I don't actually know where that is on this map, for more than 5 days a year. Then they're going to go to the next level of adaptation, where if they have two 1.8 meter floods in a year, then they will go to the next level of adaptation. And then the third level is if the barrier dune is breached and there's permanent inundation, then I'm sure that at that point you're talking about retreat. So the point here is that you don't have to make the investment today for protecting your community from the risks that are likely to occur in 2080, but you should be thinking about a pathway to get from the decision that you're making today to that outcome that you may have to make that decision in 2080. This is just a diagram trying to illustrate the incremental versus transformational adaptation idea versus adaptation pathways. In this diagram, essentially, if the current policy is here, you have a decision point to go with one of these four options here. Action A actually gives you options that go all the way through without having to change course. Option C, you would have to change course in I guess this would be 80 years and go to one of these other options. And option D also gets you all the way to maybe 100 years out. But the point is the current policy isn't going to work, and you may have some decision points where you move between these actions because they will have different costs and benefits at that point. So I think this is a very hopeful thought process. It may not work in all cases. There are examples with dikes that they build dikes broader at the bottom than they would be otherwise, because you could then add another layer of dikes above the base if you need more protection against sea level rise, assuming you thought dikes were a good idea. But the point is, lots of people are really constrained by the array of risks and the magnitude of risks, and not understanding how quickly they're going to need to have these investments in place. But there are ways to help them through that process so that, yeah, let's make these incremental short-term decisions now and make sure that we set a point where we're going to make another decision with more information in the future. So I'm not going to switch and just briefly share with you these ideas that came out of this Hauser webinar that I mentioned, where these other folks were working with me on these topics. The questions were, how should the United States be thinking about and planning for adaptation? What actions are current decision makers taking to adapt, and what further actions are needed? And how can the social and behavioral sciences be used to advance adaptation policies? We chose to think about that in the context of a new report from the U.S. Global Change Research Program, which is the 13 federal agencies that focus on climate issues. They had just issued this report on their research priorities. And I think they did hit on some of the themes that we all agreed needed to be dealt with, but not perhaps all. Research and coordination are needed to better understand the efficacy of adaptation practices, which brings me back to yesterday. You know, if we aren't setting ourselves up to learn, how are we going to know about the efficacy of adaptation practices across all these scales? What additional efforts are needed? Current and projected economic and social consequences of policy choices, processes of decision-making to manage synergies and trade-offs, and synergies and trade-offs between different adaptation and mitigation options, which is explicitly focused on this topic today. We chose to focus sort of within these questions on how to ensure the most vulnerable are protected, how to reduce incentives for maladaptive behavior, because a lot of our existing incentives, for example, insurance and FEMA and so forth, really encourage maladaptive behavior, sometimes, not always. How to scale up adaptation efforts nationally and globally, how to ensure just transitions that are economically and socially fair, how to think about water-related adaptation efforts, because they're a good example of being able to combine those often, the adaptation and mitigation components, and then understanding how policies and politics intersect to avoid culture wars, because an awful lot of what we're seeing in what I think is a pretty dysfunctional place in our democracy is people are not being governed by facts. They're being governed by sort of thought leaders within their own cultures. So just a few ideas associated with just transitions to renewable energy. This comes from Dan Kamen, who is currently a senior advisor to USAID. Obviously, as we have more heating and cooling demand, we are going to need to adapt the built environment. That will have particular consequences for poor people. Distributed energy generation is a new paradigm and provides the opportunity to adapt in the Anthropocene. So this new way of delivering and generating energy really does give us new tools to deal with issues like social justice. There are ongoing innovation pathways for solar, wind, and energy storage to help support distributed clean energy. They can be more on-site, more secure, and to address increasing climate-related disruptions due to fires and droughts, for example. He also said that a just transition requires more equitable opportunities for women, at-risk youth, underserved communities, and ethnic minorities, which can be in the form of job training for the new economy, especially in regions left behind in the energy transition. And that we need to think a lot about the materials that we are using in this transition, because we all know, for example, batteries have really significant environmental impacts. How can we do green recycling and green mining and materials transitions so that we're supplying the clean energy future, but also reducing the damage of extractive practices we have now? And then Michael Vandenberg, who's an attorney who really thinks a lot about the social science and politics of climate policy, is very concerned about communications and how do we reach particularly those people who aren't fact friendly or who are really intimidated by the sort of dominant culture and feeling disenfranchised. So we need to find common ground, and that's a big communication challenge. He's really concerned that if we talk too much about managing risk, that we won't have the incentive to invest in mitigation, which is an argument that has been going on for 30 years now. A lot of this actually happened with Al Gore. He felt like we shouldn't talk about adaptation because we couldn't take our eyes off the ball, and the ball was mitigation. But as I hope I've illustrated, we don't have a choice anymore about whether we're talking about adaptation or mitigation. We really have to be thinking about both. And so how are we going to do that in a way that doesn't discourage people from making mitigation investments? And think beyond the role of the federal government as the savior on the white horse, because obviously the federal government has not been charging in a very effective way, and think more about how private sector interests can really influence the conversation and actually provide governance. He was also suggesting that we think about the feasibility of adoption of adaptation actions, that requires much more rigorous social science research, and also thinking about intra and intergenerational issues. And I think this is maybe one of the most important places that we can really change hearts and minds, is reminding people that, you know, they either have children or are likely to have children or know people who have children. They may already have or will have in the future grandchildren, or know and care about people who do. And so we can't think about this in terms of just this generation and our own benefit. We need to think much more long-term. And how effective is that argument in changing hearts and minds of people who are currently really feeling angry about this whole topic? So we need to leave behind mental models that are really constrained by ideologies and do more reaching across the aisle and finding common ground, which hopefully will lead to a range of options that doesn't include just the federal government, but state, regional, local, and private solutions. So I'm just wrapping up here, but to sum up pretty much everything that I was talking about yesterday and today, really defining success is the underlying theme here. Are we focusing our investments on measurable improvements in human and environmental welfare, or are we basically missing the mark in terms of outcomes? So really paying attention to whether what it is that we're doing is having the desired effects. And I will close by just talking a little bit more about the path forward, assessing adaptation outcomes, costs and benefits of action versus inaction, who are the winners and losers, the potential for adverse consequences, monitoring for effectiveness and figuring out what the metrics are, deciding when to move from low regrets options to more significant higher investment options, and taking into account environmental justice and equity issues. So with that, I will give a brief plug for my own center, which actually focuses on a lot of the issues that we've just been talking about, bridging the gap between science and decision-making, managing risk in complex systems, supporting transformational adaptation and preparing for extreme events, and finding synergies among adaptation and mitigation strategies. So thank you very much. I will, we can turn off the slides and see if any of you are still awake and or if you have any questions. Thank you.